All right. Here we go. You. All right, we had some very interesting discussions here at work with people that already implemented this stuff. And someone indeed implemented this as memory. Excuse me. So let's just do that maybe at some point. Maybe let's keep the to-do. Right. So I think where we were at is this part here. We had a failing test. And it was returning 5 literally instead of the position 5. And one of my colleagues had a brilliant solution for that. He overridden the getter on memory so that you can't, I mean, you could do make this into a pointer, but depending on what kind of thing it is, what kind of parameter it is, you pass something else into this memory getter basically, and really neat. We're definitely stealing that. So since we have addition here, we can see, well, it is addition current instruction. So what we should do here is check current instructions, get parameter 1 or something from the memory at memory.pointer, and this should return param1, and this should return a parameter. So parameter in our case is either a position mode or an immediate mode parameter. Let's go back there, because we can create it based on an integer. And this thing here returns an int code, I think. And an int code is a string for now. So that's the other thing that we noticed, is that maybe it is indeed better to just wrap it in an int code object that we threw away before. But yeah, maybe it should be fetch parameter or load parameter or something. In fact, I think I made a little mistake. But we'll figure that out soon. So I want that to happen in addition, I think. Well, at least for now. And this is an int code, which I guess is a string now. And the thing I want returned is... wait, hang on. That's not correct. I need to pass the memory and the pointer. Just the memory. So what I should do is, let's call it memory. And then fetch position. So if it's position, I want to do this. Pointer. Let's do it like this, make it a little bit more extensible for later. So this would be... Alright, now I think I want to change my int codes into ints instead of strings. I think it's best to do it right now, otherwise I'm gonna be in a world of hurt later. Yeah, let's change it. Alright. So back to square one, where these things are integers. Yeah. Okay, they're int codes. And then int codes. I cannot make up my mind, apparently. The thing is, I want this, which is memory. Parse into memory. I want this memory thing to be a list of something like integers, for example, but things I can do something with. For example, in this case, this is a position. That would be position mode. So in that case, I think pointer would definitely be an int. Yes. And then I think memory should also be something that contains integers. So let's make it int in any case. Now I bet there's a bunch of other stuff. Whatever's. More stuff that's not compiling. So this is no longer a string. So I think I can rename this to integer, maybe. And then say it should now be an integer. And then what I'll do is I'll transform this into there we go. Because leading zeros are gone anyway, so let's just do this. All right. And here we do want to first transform it into integers. So let's do map it dot to integer. There we go. Okay, and now I will change this, the type, to int codes, in fact. And then int codes can be a type alias for a list of integers. There we go. And now I think I can gradually make the difference between what is an int code and what is an like a pointer. Here this is going to be an int code, in fact. And what I'll do, where I have the type alias int codes, I'll also make an int code type alias. And then call it int code. So currently an int code is the same as an integer, but we don't care a lot about that. Okay. All right, cool. What the hell is this? Require position. Ah, yeah, that's like a util thing. Where did I put that? In fact, oof, that's far from the code. I guess it can be private. Right, and here we are making an addition. So that's this thing. Let's see if what the status of my tests is like. Not very good. This should be called endcode now. This thing doesn't exist, in fact. So that means this is just it. And then I can get rid of these. Get rid of these. There we go. Right. Oh, more stuff to fix. So let's map this, I guess. Or I could just remove the quotes. Maybe it'll be better. And let's do that here as well. There we go. Now let's run all the tests again. Hope you're doing well. Did I run the tests or not? Because doesn't look like I did. Let's just run all of the tests, maybe? Oh. Do I even use this now? Okay, I seem to do, but maybe this should be a list of integers here instead of strings. And there we go. And then this can just be ints, which are integers, which can be ints. There we go. To list. Yeah. All right. Okay, so now we're finally back on track, I think. What do I want to do? Right, we were at this thing where we expect it to be a parameter value of 2, but instead we get 5. And that's because this is just a literal value that's being used and not the memory at, or not the value at memory position 5, so, which would be 2. So, the idea here was to, what was it again? To load the parameter. And this thing was going to return a parameter. So based on what I already passed to this instruction, which should have, since it's already an addition, it should have 2 modes for both parameters. And then if we say load parameter 1, I think what we should do, hey. I think what we should do is do something like this. So parameter 1 mode dot load memory. So this is basically what I want to do. So load from memory using this pointer, but I want to rewrite this as this. Oops. Pointer value or something like that. This is looking horrible, huh? I don't think it's interesting anymore to do this, is what I've come to think of. It just needs some kind of immediate value at the moment that I read it. The moment that I basically parse. Wait, maybe there's more of these. Fix all. The moment that I basically want to load this parameter 1 is also saying that I want to copy it like that. So maybe the thing I want to do is I want this to return an instruction already, instead of doing a copy with parameter 1 maybe. So this should return an instruction. If that makes sense. And what I can then do is I can write some unit tests for this. So let's go to our tests somewhere. Do we have like addition tests? No. I gotta tell you, like next time I'm no longer making objects in the same file. So let's do addition or load parameter. Is input mode or is immediate or position mode. Returns new addition with param from memory position. And then the other test that goes along with it is immediate mode returns new addition with from pointer from memory at pointer. So let's make an addition and then say the input mode of 1 is position mode, and then we'll do whatever, and then parameter 1 is null. And what I want to do then is load parameter 1 with, I think it's still called encodes. Yeah, let's call this memory from, so this is annoying because now I need valid memory. So let's call this actual, and then assert that actual is equal to this addition object. And as parameter value, not null, but the value at position 5, which is 2. And then we'll do the same for here. And then make this a 1. And then it should be 5. And then this should of course be immediate. Oof. I don't have a test for this, I think. Yeah, from a valid string, it's no longer a valid string. Let's actually add it. So this thing is equal to an addition of twice position modes. Curious to see if this works. Damn it. I kind of want to say like prepend with a 0. Okay, I think I'm going to put that in int code itself. Okay. Okay, now I've got stuff from it. It will always have an operation string and then the rest, I guess. No, it's not true. It will always only have an operation string, and then maybe also the rest. Yeah. But I always give it the everything. So okay. So these can become to string or like full string or something. Full string, something like that. And then this can become input get operation or opcode. So now we can write that as this. Okay. Or I could just do this and it's the same, and then we'll overwrite to string on endcode. So now endcode is no longer just a type alias, but a data class. Takes in yep. Not sure if you can do that. Yeah, you can delegate to an int. Okay, that's okay. So the toString of this thing is just going to return underscore value. And the thing I really wanted is opcode. Yep, which is a string, which has just a get, which should return something I had in... No, I thought I had it in my copy buffer, but I was wrong. So let's see if value is larger or smaller than 10. We'll only have a single digit. I want to return value to string, and then prepend plus, well, I guess we can just do this. Ah, yeah, of course. Otherwise, we will return value take last or something. It's still in my Scratch file. Yeah, take last. First to string and then take last to. And then we'll just return, and then it can become an equals, and then we'll put it on one line. there we go. Okay, now let's see what's not compiling anymore. Let's provide that constructor, in fact, just to give it a little bit of more developer friendliness. So we'll get int codes, which is a list of integers. And what we can do here is call this with int codes dot map. Oh. Map int code from it. What the hell is the problem here? Okay, I guess that's that. And then here, okay, a bunch of stuff is not compiling anymore. And why is that? Because it's now an int code. Ugh. Okay then. Guess I multi-cursored too much. Mm-hmm. I guess this is more readable. Let's rerun the tests. Could not parse into an addition. Right, I need to update the toString. And just return underscore value.toString. Yeah. Now let's run all the tests again. So we were working on that. And then here. Yeah, and these were new tests. And this is the example, which isn't working either. Okay, cool. Phew. Okay. Where are we at? I think. Oh yeah, we were here. Load parameter 1. then parameter 1 is in fact 2 because it's this thing. Okay. Great. Now let's maybe we'll first implement this here and then move it to this, for example. So what I want to do is so memory at the current pointer, and then load that thing again. So this returns a what? An int code. I guess what I could do is something like this. Or default to position mode. So in that case, I can write a test for that as well. What was it again? Load or something? No, like custom getter or something. Get returns value of memory at memory index or something like that. With mode. Okay, so that would mean if we create memory with something like this, and we say, so the memory, and we do memory like this, for example, then we expect this to equal 1. Like this. And then if I pass along the mode, like this, immediate, Ah, yeah, no, it's incorrect. So if I were to take memory at 3, 1, 2, no, 0, 1, 2, 3, so that's taking it met at 4. So that would mean 5 here. And here it should match. Maybe this makes a bit more sense. Okay. Override get. Well, overload get. Mode, input mode. So if it's immediate mode, return get with index. Else will return so we've got int codes here. All right. But now I want, oof. This is actually incorrect then. I want int codes at index, and otherwise and then make an encode from this even. Oh nee. This is the index that I want to use, right? So here we would get in our example. Oh yeah. We can rename this to immediate, I think, yeah. Oh, I do need to overwrite get by forwarding to with index and position. So I guess I can't do this anymore. So we'll fetch this. And then this is going to produce an int code value, and I want its internal value. But there's no way I don't have an access to that. There we go. I do now. In that case, it's kind of silly to do this. So there we go. Yeah, so these always will return int codes. Let's ask a value. Oh, it's still trying to ask for 20. Okay, now I can be a little bit more complete. Memory tests. So I wonder if I do this with position. No, okay. So it is in position mode. Yeah, I think it's just this. And then wrap this in an int code again, or what? Breakpoint. Excuse me. Let's just debug this one. Okay, let's see. We just did a call to get. Why is that? Because we're in partially execute. In the wrong method. Here, in position mode. Also, not the test I wanted. Okay, here we go. So we'll do assert memory with position mode. And then we'll get the value out of that, which should be 20. And instead, we're going to get an exception here. So where are we at? So it is position mode. Index in this case is 0. Is that correct? Yep, it's 0. So it would be 1. It should return 1. This thing should return 1. All right. But so if I would do int codes at value 1, it should return 20. Okay. So that's 20. So then dot value should be 20. I am confused. Okay, so in this case we're at memory 1. So that's index at 1 is 20. Oh. I'm dumb. Of course you can't do that. Okay, and I think I want to switch it around, in fact. Position mode. Okay. And then the default get should be so this should be more like this. And then this should return 20. So this is already going to be the case, but then I want to default to like this. And then make this 1, 2, 3, 4. Make this into 1, 2, 3, 4, 5. And then we'll change this thing around to use immediate mode instead of position mode. Okay. Next. Now we can just pass along the mode to the encode thing. And then we can assign it to, we can say this.copy and say parameter 1 equals this. Oh, apparently it's an int. Let's make it an int code. No, because it really needs to be an int though. Value. Something like that. Okay, curious. So we've got two position mode parameters. this is the memory. So this should be the opcode of the memory. And then load param1. Oh, it doesn't have a pointer yet. That's probably why. Increase pointer. Yeah. And we need to do the same here. So because we've already read the instruction, the operation, the pointer should have been increased. That's why. Okay. Looking good. Parsing into memory seems to work. Bunch of green tests. Executing instructions. Somehow. Okay, I was gonna say. Interesting that it already works. We haven't done the addition. So we need to do both of these for load param2 as well. Same thing here. That thing doesn't exist yet, and we need to increase pointers here. And then what do I expect? This is the addition opcode. This is first parameter. This is the second one. Yikes. So what happens if it's -1? It should probably explode. Parameter 2 is position mode, but is... Well, hang on. We also have to do the same for parameter 1, in fact. It was this one that I needed to copy. And value of param1 is negative. Throws exception. Hey, Lat Dior, thank you for the follow. I hope you're having a great day. So this, in fact, should return an exception. Exception of type. Is thrown by this block of code, and then we can get rid of that. This is the same block I want here, but then for the negative value 1. And we want to do load param2. And let's also make our text look the same. There we go. Cool. So that means I need a valid working test for position 2. For parameter 2 in position mode. So parameter 1, parameter 2. Let's make that into One should be fine, so that would give us 5. And if it's immediate mode, I want it to be -1. Yeah. Okay, now let's create this member function. We can refactor this stuff later. So it's memory. I want it to return a new instruction. It's going to look exactly the same, in fact, but for parameter 2 mode. And then we'll say that parameter 2 is that thing which we don't have yet, which is fine. One too many commas. Okay, there we go. I guess it should be in the getter of that memory thing, right? Memory. So if this is just delegation anyway, so only if it's position mode, if the index that was passed along is maybe we can require positive or something. No. Okay, then if index less than 0, throw a legal argument exception. Can, well, try fetching memory at a negative position $index. I guess we should have written a test for that, right? At memory. So only in position mode. Get with position mode and negative value throws exception. So -1 or whatever, we need to throw an exception. Let's run this one. Okay, so that fails. That's great. And then, oh sheesh. This is weird. Because I do end up in this one. Where does it throw this? Oh yeah, of course. It's this one that I wanted to fail, huh? Mm-hmm. Okay. So I think we're not yet. So memory we can skip, but oh yeah. No, because I'm not doing that's strange. Oh, yeah, it's parameter 2 that I want. Parameter 2 equals, and same here, parameter 2 equals. However, it might not be -1. Nope, this is correct. Here it is 1, so that is 5. Okay, cool. Let's run it again. All right. Oh, slowly but surely getting there. So now I've got a way to gradually increase instructions. And here I think I want to not loop. So what I think I want to do here is I might want to increase the pointer outside of it. So if it's addition, that means I'll already have an instruction. So that's not great. I think what I want to do is do this. Instruction from int code. So this would be immediate. And I do pass memory, so maybe... Yeah. That means all of this should return a pair of memory and an instruction. It's been ages since we last made a commit, so partially addition, or actually creating addition using memory or whatever. So now I would only have load parameter 1. I think what I can do is load parameter 2 and then also increase pointer. Um, but so that would mean that every time I do something with memory, I want my memory to have an increased pointer. And these belong together. Okay, maybe I want to write it like that, maybe then. So, let's do this, updated memory maybe. Updated memory. Let's switch these around and to memory dot increase pointer. And then here I can do oh shit, I want it like this, because this returns an instruction, right? Yeah. And it's an instruct. Wait, where did I put load parameter 2 then? This is on addition. This is also on addition. Oh no, it loses. Ah, shit. Yeah. To memory increase pointer, increase pointer. So that means I can start completing that partially execute. Didn't I have like a... Yeah. So then I can do this one maybe. Oh, wait, why doesn't it fail? Oh, I haven't ran it yet. Yeah, okay. So that's what I expected. So I will have both parameter 2, I mean 1 and 2 filled in. And it will have yet another increased pointer, so it will have ran 3 times basically. Maybe I can make some... Yeah. Pointer at or something. So I think initially it's at 0, eh? So that means that here it should be at 0 plus 1 plus 2, so 3. And this thing doesn't exist yet, and I want to... Oh. Which is an integer, which returns a new memory, which does this dot copy with pointer, new pointer. Well, what's it called then? Jesus, I'll need to increase it or something then. Oh. And this is private, so maybe I can update it. Oh, lucky. So now in my tests, I should be able to use this. Yeah. Great. And what do I do next? So parameter 1 should be 2, and then the other one should be... it's an immediate value, so that should be -1. Ye gods, let's run it. Yay. So here we are complete or something, I don't know. Okay, I think it's time to move these into their own class, because this is just silly. I want memory to be there, sure. And then I don't think I'm using this anymore, so I'll just get rid of this. Bam. Kom maar, hè. Moet je wel zwaaien.
Wanneer mag ik zwaaien?
What is some other stuff I can extract? Instruction for sure. Oh my god. Yep. Let's move instruction into its own file too. Where does input mode fit into? I think I use it both for instruction and memory. So maybe let's keep it here. And then also maybe let's put int codes into their own thing. Ooh, and here there's a... This should be called parse into memory. And this belongs in memory, huh? Can I move this to... Aha. Okay, so both of these things, let's move them to an int codes file. Let's add int code as well, please. There we go. Alright, and now we can extract all of these tests into their own things. So, yeah, memory tests, they should just move to their own class and an own file. Hoppakee. And then load. What's this? Addition. So this could move to instruction. Instruction test. And then parsing or instruction from int code. That's also an instruction. So let's move these. Let's also move these there. I think I might have copied too much. But we'll see. That's the annoying part. Now I need to do all of these static imports all over again. So actually this thing wasn't useful anymore. And then this partially executing, actually, this is no longer parse input. This is partially execute. So we need to take this out of here and into date 5 tests. I don't think they're called parsing into instructions anymore. Parsing into memory. Let's copy this into... And this is no longer a question I have. Should belong to the memory test. Okay. And then let's do some... int memory. Yep. Add imports. Let's also add imports for this position. All right. And then what? I think we should do that here as well. That way we've got some cleaner code. It's more concise, more readable, hopefully. And then this is basically test functionality specifically for memory now. So let's rename that to memory. Okie dokie. Now we can supposedly run all of these and check if it's working. Yo. Okie dokie. Parsing into instructions. Do I have another one here? Two separate files. All right, so I think now when I read the next part of this memory here, how do I go about that? Because if I partially execute it, what's the problem here? Oh, I only have addition here. Okay, yeah. Yeah, we can just leave that there for now. So I think whenever I do load parameter 2, especially for addition, I can guess it's complete, and then I should execute it immediately. Oh no. And then once I execute it, I can return null as an instruction instead of... Okay, well, you could say, or you could argue, well, why did you write all of those tests now? Because it's going to change anyway. My implementation, I mean, of partially execute, but it's the tests that brought me there. So I think it's okay to remove them right now. This, I think, is just going to remain loop across this or something. And I'm afraid that I'm overlooking something if I don't tackle it now. I mean, looping across this memory thing. Because it's starting to look like a reduce fold, something like that. With an instruction of null. Yeah, anyway, I think I can get away with it at some point, so we shall see. I wonder if I'm... No, I think it's fine like this. But I do feel like I need to execute it. So in that case, if it's already an addition and I have an instruction, what I think I want to do is do both of these and then execute it. So this is going to be create or complete and execute addition. And here, well, I guess what this should return is not just an instruction, but memory as well. Because now this thing belongs with this execution. So that means this thing should return to blah. And in the end, it'll just have to increase again after, and that is after I execute it, and then the instruction becomes null. Yep. And then I'm ready to start a new instruction. Okay, I think that's it. So this is completing. Hey. And then complete addition should should also do this. And then I want execute. With memory. Well, actually, no, with instruction and memory. No. Allee zeg. All right. And then I want to instruction execute using new memory, which should return null. Oh, great. And now it's a question mark. And it's this that I want to execute. Okay. And everywhere else, it is still compiling. Cool. So now we can implement this on addition. Oh, and I think we sort of already had that. Now I was browsing. It should be on instruction. Yep. And here we've got addition. I feel like it's got a bunch of parameters now. I mean, too many for good readability. Okay, so let's write an execute. which takes in memory and returns memory and returns memory as an implementation, and then we can start writing tests for that. Load blah 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 is boring stuff. Test. Execute. What do I want to test? I haven't completed it yet because I need a destination. Nice. Adds param1 and param2, stores it in param3, or maybe we can use a destination for that or something. Destination. So that should be my eventual implementation, but the thing I still need to do is load destination. And this should still return an instruction. And this looks exactly like this, in fact. Where I'll have a destination. Doing a great job again at doing test first, aren't I? Destination. Now the question is whether or not it is an int. If only I had some kind of representation that you know what, this thing actually should belong in the input mode thing, which is here. So let's move that out of there. And then we can move this out of here, and then say input mode dot put mode from C, and then let's create oh no. Oh. There we go. Okay, now I can inline this, hopefully. Yay. Okay, whatever's. Dag Nele. Right, let's do load destination. I guess that thing can also not be negative. There's also no way that that thing is not position. So we want these. But for load destination. Something like that. Okie doke. Value of destination is negative. That's this one. So let's make both of those available, or just position mode. So that would mean, yeah, this is fine, I think. So this should explode. We need to do this so that we start parsing from here. So that was just because I had a failing test, but it was a false positive. I mean, a working test, but it was a false positive. So now we need to be at position, pointer at, I think 3. I will know 4. Because I want 0, 1, 2. I was wrong. It should be 3. And these, let's also transform into pointer at 2. And then maybe the single increase pointers, let's do pointer at 1. All right, so load destination. Destination is always position mode. So it's not a conditional, so destination's value is negative, throws exception. Not negative, I guess. Or positive. Returns new addition with destination from memory position at pointer. Yep. So that means we also need to call load destination. And then I don't care about these other things. I specifically care about the destination. Then, oh my god. To be equal to 3. And here it should also be pointer 3. Oh, hang on. So in fact, it's the value at that thing. So it's never position mode. In that case, I don't think I want destination to be an integer, but I want it to be a memory address or something. And this will put in memory. Let's make it an integer. So this pointer, I think, should also be an address. This is where we had the execute. Okay. Okay. And it's not parameter 2 mode, it's just this. Cool. So that way I know that when I finally execute it, I need to put it at this memory's address, basically. Okay. Let's do instruction test again. So it should be 3, right? Yeah. This is important. Okay, let's run these tests, because I don't think they'll be working. Okay. That's weird, no? Oh, it's probably the implementation. Nope. That is indeed different. I think where I put it before was in that not negative thing, was in memory itself. Yeah, I tried fetching a memory at a negative position, which you're not doing now. So now I try to put it in an address, and an address is in fact an address can't be negative, so maybe we'll add that to this thing. So this is no longer just a type alias, but let's make it, give it some more which is an integer. And then we'll do an init and then check acquire. Dang it. Check. Dang it. If value less than 0, throw legal argument exception. An address can't have a negative value. Whoa. Oh, okay, so let's operator fun plus, I guess, another, maybe an integer? Should return a new address. Should return a new this dot copy value plus value. Jesus. So it's this dot value, I guess. So now we can just do +1, huh? And we have 0 tests for that, so let's add them. Let's write some tests for that. So we can do 2 is equal to address of 3. Let's do a bunch more, maybe. I think we only have addition for now, so maybe it should be okay. So that should be 1, and then 1 plus 0 should also remain a 1. So if I go back to memory, where we had overridden that getter, I'm wondering if it's always an address that we're using here. It's only when we use pointer though. Where was that? So I think in instruction we're also, yeah, it's always with pointer. Okay, I think what we can do then is go back to memory and make this index thing an address. Yikes. It doesn't override anything. Now I'm not sure if you still can use that syntax with this. Okay, crap. Now I also need to implement less than. Actually, you can't ever do this because it's an index. And then I guess this should return a new... This should return a new address, I was going to say, but here it really is fetching. And the other one is just illegal now. What? Or what? Oh. Oh, then you can. Okay, nice. Oof. Yeah, okay, so here we need to deliberately transform it into an address. Okay. Okay, so now this has become an impossible... Whoa. That's nice, huh? Shit. So in my code, like I never... Wait, hang on. Yeah, because it's always a pointer coming from a memory. Yeah. Let's run it again. Right. That is correct. And there is another place where it's not compiling in memory. Yeah. So, yeah, we want to keep this... Yay. Wait, so that was just the overload of... Okay, I don't care about that, do I? So my instruction tests now should have working load destination. All right. If we go back to day 5 now, right? Yo, Salicus. This complete addition thing. Needs to load parameters. Needs to load destination. Dude, this sucks. I guess what I'm missing is that load destination should not only return an addition, but also a memory, an updated memory. So every time you actually use this memory for some reason, you need to make sure that you update it. And that's now it's if I forget to do this, for example, I basically break it. So complete and execute addition. This load destination we tested separately. Now we've got completed. So when it is completed, I can then execute it, and now we can actually go back here, go to execute, and then this should read execute addition. All of these basically are addition tests now. There's nothing generic about it, I think. Well, this is. So let's try and create an addition of maybe this thing here. Oh, something that is legal. So that means we've got an addition in position mode, another position mode, then parameter 1 is 1, no wait, -1. This is going to explode. Where did I copy that from? Oh, this is just load parameter 1. Okay, that's why it... Bad example. Let's make it... Okay, let's make it an immediate mode. So that means the first one should be immediate mode. So that looks like that. So the first parameter is -1. The second parameter should be the value at position 3 at this point in time. So that is 0, 1, 2, 3, which is in fact itself just 3. Maybe we can make it 5 or something. So that's 0, 1, 2, 3, 4, 5. Let's make it 5. So that's 2. And then the destination should be 5 as well. So that means if we were to execute this using this memory, memory, oh right, and then also pointer at yeah, that's a good question. What is my pointer going to be at when I'm done with complete addition? The time of lean coffee is nearly upon us. So I might have to. I mean, I need to make sure that this stuff gets done before that. Or I can just drop it at some point. I still need to do multiplication. It's going to involve some stuff. No, but let's think. Yeah. So we've got load parameter with just the memory. Because we did this, so in that case here I think memory already was updated because we have an instruction already. Yeah, okay, so this is pointer at 1, pointer at 1, pointer at 2. Oh yeah, actually pointer at 1, 2, 3, 4, so it's at 4. So 0, 1. Yeah. 0, 1, 2, 3, 4. It's already at the next. Yeah, that makes sense. It's after it executes. It's only after it executes though. But we already have partially execute though. As a test function, so we can also just see what this does. Memory after execution or after addition. Memory after addition. Oi. Is equal to well, this, but then addition applied, so that means we were going to store it at address 5, so that's in here if I'm not mistaken. So that's -1 plus 2 means 1, and I think this is position 5, so that becomes 0, 1, 2, 3, 4, 5, yeah. All right, so it didn't change, so that's good. Now let's execute this. Oh, and I think the pointer should also remain. No. I don't think this makes any difference at all, because memory extends from list and the list is equal because of this thing. Where is it? By int codes, and an int codes is a type alias for a list of int codes, and they've got equality checks based on this. Well, actually, no, of the value. Yeah. Fucking hell. All right, and now we need to apply addition. So that means this dot parameter 1. Oh no, and it's a possible int, but we know for sure that it's filled in a parameter 2. This is the result. Result. And then I want to store it at memory. I'm not even sure if I can do that. Aha. Destination. See, I can't. Yeah. So I'll need something for that. So I want set? I don't know. And it should be an int code. Yeah. I think it's also an operator. Must have at least 2 value property. Okay, I'm right. Value int code, I think. I'm not sure if you can. I think it's a unit, in fact. And what do I need to do? I want to go int codes with index.value equals shit. I think I need to do this. Then it's just delegation again to shit. And now I run into the problem because int codes is just a list and not a mutable list. So yeah, and then this doesn't return a new thing. Let's get rid of this shit. Type expected. Okay, I want my memory to be returned, and I want int codes to be updated to mutable list. And then what I can do is say new int codes at index.value equals value. And then this dot copy int codes equal encodees new int codes, and return this. Yeah. And then I believe you should be able to do this. What's the problem here? Oh, I already have an address. God damn it. All right. And then this is not an int code. So let's make it an int code. And then return this? How does that work? I'm really curious if this works. Ran the wrong thing, of course. It doesn't. Hey. Ah. No, both things were incorrect. No, it should be at 5 for sure. But the instruction execute should do this and then increase pointer. Okay. That does work. So then there's no use in this notation, huh? Or in this being an operator. Yeah, okay. Well, there we have it. Now let's go back to, I think, day 5 test or something, where we do partially execute. Or, you know, run all of the tests. See where stuff is failing. Oh yeah, here so since I can complete the addition in the second part, it should be null, this thing, and the pointer should be at 5, I think. or not? Oh, right. Now it's applied. Derpy derpy derp. Ah. So it's memory after addition. All right. I completed something. Completed executing addition. So I think the rest shouldn't be that difficult anymore now. But that's assumption now. Great. Let's push this. I really need to go actually because it's Lean Coffee starts at 7 and still need to eat, still need to drive there, which is going to take me a while in this traffic. Oh, and then I still need to walk. Okay, so I think I'll just walk there. And then tomorrow we're having a hackathon here at work. Maybe I want to show what I got for that. Yeah, let's do that. If I end up being alone, I think I'll stream. I will stream that. So that's no, I think it's event sourced Magnum Sol. So there's this board game called Magnum Sol. You play salt miners in the famous Polish salt mine of Wieliczka, and I want to play around with event sourcing this, so that's the idea. So if no one's joining me tomorrow, I will stream this. And if not, well, maybe I will do it in another session afterwards. Okay. All right. Thank you. Thank you for hanging out. Hopefully, I will see you next time. If not, that's fine as well. All right. Be seeing you. Peace.